Okay, so we're still in chapter 14, which I mentioned that last week. That will be in chapter 14. And we're continuing with multiple linear regression. I'm just going to abbreviate it. So MLR, multiple linear regression. So like I mentioned today, we're going to introduce that categorical variable. This is called an indicator, or we could call it a dummy variable. So this is where we use a categorical variable with two levels. So we should be familiar with the number of levels. So it's how you can answer a question, right? Like a yes, no kind of thing. So with two levels, right? So it's not like where you can have 5 different answers. That'd be 5 levels, 2 answers, 2 levels. And we use it as a predictor variable by coding the 2 levels as 1 and 0. So there we go. So we're going to take this categorical variable. It can only have 2 levels, and we're going to code them 1 and 0. So it's a yes, no kind of thing. It could be like, I'm going to give you a kind of a verbal example of male and female, right? And that's how we're going to introduce a categorical variable into our linear regression model, okay? So Minitab can actually do this coding for us. You'll see in the typed notes where the instructions are. It's like you go to data, I forgot. It's like data, code, and then numerical or something like that. It's a very quick process. I'm not sure if I'm going to do it in an example or not. I may, but those directions are there. It's pretty quick and simple. So Minitab can do this for us. We can tell it what we want as a 1 and what we want as a 0. Excuse me. So that's really nice. So let's just kind of talk about just a little verbal example. I'm not going to show you anything in Minitab just yet. If maybe we want to study salary as my Y, my response variable. And maybe for my predictor, we're looking at age. Sorry, I'm so sorry. I'm having like an allergy issue. Sorry, excuse me for the sneeze. We're going to study age as a predictor, number of years at the company as a predictor, and I want to study gender as a predictor. So gender is not numerical, right? Age is numerical, number of years at a company is numerical. So that's no problem. That's what we've been doing. Now, if I want to introduce this categorical variable, gender. So maybe what I would do, I'm going to say, okay, this is categorical. Then I'm going to code it. So maybe I'll say, okay, well, a 0 means that you're male, and a 1 means you're a female. That kind of thing. Okay, so now we can take this gender, and it is categorical, but it looks to Minitab as numerical, 0s and 1s. Okay, and that's what we're going to do today. And we're going to kind of talk about how to view this in the model, how to build the model with it, and how to interpret everything and look at it all. So let's start right away with the matrix plot. So that's my scatter plots, right? And how we introduce this categorical variable into it. Okay, so this is like under my getting to know my data kind of step, right? Where you're just looking at what you have going on. So here I have my matrix plot. So remember from last week, the matrix plots just scatter plots, right? It's just multiple scatter plots. So it's going to be scatter plots of my Y versus each X, right? And then we also see the scatter plots of X versus X as well. So now we're going to look at these multiple scatter plots, but now since we're introducing this categorical variable, we're going to call this now with groups. Okay, so multiple scatter plots with groups. So I'm just going to put like a little asterisk here, so and say with groups. So hopefully that indicates to us that when we're in Minitab, we need to ask for this with groups. And the groups are the zeros and ones for my categorical. Okay. And that's what we're gonna, how we're gonna put that in there. So it's actually a simple step because we'll already have our data coded as zeros and ones, and we're going to say with groups. Okay, there we go. Focus that a little bit. So let's just take, I'll just do a little drawing about, you know, what this is going to look like. So if we have this scatter plot, it might look kind of like this, right? This is what a scatter plot looks like. And maybe we have male indicated with red squares. Remember, a male was 0. And then maybe we have female indicated with a circle that's blue. And this will be shown on my scatter plot because I'm going to break it out with groups. So it will look something like, might be like this, like that, okay? And then the female will be the blue circles like this, okay? Like that. So now I have with groups. So now I have the scatter plot, and I can look at the scatter plot and I'm looking at this red box versus the blue circles, right? I mean, you can't help but notice that. So when we do this, let me kind of do it like that. Okay, there. I'm looking at salary versus age, okay? And then it's broken out by gender within that, okay? So when I'm looking at this, I really want to look at the relationship that's going on. So I can see that age and salary have a linear relationship, right? So we would look at this normally. And then we want to know if there's an effect of being a male or female. Like the gender has an effect on the categorical. I'm going to write all this down. And what we're doing is we're looking at a separation by color. So what I'm looking for, are there like a lot of reds up on the top half and a lot of blues on the lower half, or vice versa, right? So a lot of blue, like, is there a clear separation? And that's what we're looking for to see if gender has an effect. We're looking for a separation. So what it would look like is if you had like a whole bunch of like maybe red boxes all along the top and then all the blue circles were along the bottom, there'd be like a clear separation. This one, they're pretty mixed, right? It's kind of mixed in here. This was just a drawing. I didn't actually study this. So first we're going to study the predictor versus response. So that's what we have here, age versus salary, right? We just want to look at that relationship. So just as we usually do, is there a linear relationship, right? We're just looking at it. We can, of course, use our value to go along with this. That's the first part that we're going to do. Then, and this is all at once, then we want to find if there's an effect. So to find the effect of a categorical variable, we want to look for a separation by color on this matrix plot. So I'm going to say by the two levels. So we're looking at two things all at once, the linear relationship between age and salary, and then we're going to look to see, well, is there a separation by color? So does gender matter? How age is affecting salary, right? That kind of thing. And that's what we're going to look at when we're looking at the matrix plots. So we're going to look at this for all the different relationships between X and Y, right? We don't have just one X, we could have 5X predictors, right? In that. So we can also use our correlation value or R value to go along with this, just like we usually do. But what I want to know, and I'm going to mention this, I'm going to write it down because I want us to understand that, remember, our correlation is a calculation. So when we're looking at a correlation matrix, it's not just one number, right? It's an R value. So it's my correlation. It's that long calculation to tell us the relationship, that strength of this linear relationship. The only way you can do a calculation is when you have numerical data, okay? So you have to have numerical data. Well, zeros and ones don't really work so well with this, okay? So this is just, I'm just gonna put my table with R values here. Over here. And I'm going to mention that we do not include our dummy or indicator variable here. So we do not include the categorical variable. Okay, so we're not going to include that categorical variable here. I'm going to show you how to do this, but it's still going to do the same thing as it does. I mean, it's the same thing that we always do. We just don't include the categorical. It's still going to give us that value that corresponds to that strength in that picture that we see, right? And we use the two together to talk about that relationship between the two. Okay. So as before, we're going to interpret that strongest relationship. I'm just going to write it down. It's the same thing as last week. So the interpretation of what we see we are going to use and identify the strongest. So remember, it might not be a strong relationship, right? So the R value might not be really close to 1, but I'm going to look for that strongest relationship, and I'm going to talk about that in my write-up. Look for that strongest relationship and know anything that you notice about the effect a categorical variable has. So maybe age versus salary has the strongest linear relationship of 0.89, okay? So I would state that just as we usually do, right? There's a strong linear relationship and it's a positive relationship between age and salary. Then you're going to look and see, okay, is there an effect here? If there is, then I'm going to mention it. And if there isn't, I'm also going to mention it. So then I might just say, so I should have said you're going to mention it either way. So maybe I'll just say, okay, it appears that gender is not affecting this relationship between age and salary, right? So gender doesn't make a difference, right? Because they're all kind of mixed. But if you do see a separation in color, then you would say, okay, it appears that there is an effect. That categorical variable is changing this. So maybe you would say, well, it appears that males have a higher salary for the age than females, that kind of thing. Okay. And you would just talk about it just casually, right? You're not going to be, it doesn't have to be crazy, but we always talk about it in context, right? Okay. So that's all the getting to know the data stuff. Really nothing new here. It's just how we're going to look at it with that categorical variable. Now, let's take a look at this regression analysis, and really nothing is going to look any different. It's going to be the same as we've been doing. So remember, regression analysis is where we're building the model. Okay, so I'm just going to write same as before. And we'll see when we look at an example, it's going to be the same thing, right? And now we're going to add that categorical variable. So I'm just going to also mention this, that all predictors are included in the model, okay? So when we're building our model, we're going to include all predictor variables here, okay? I'm going to say even the categorical, right? So we're even going to include that categorical variable there. So because what good is doing everything we just did with it included if we're not going to put it in our model, okay? I'm going to show you where we put it in our model. We're going to put it right with all the predictors because now it looks numerical to Minitab, right? It doesn't look categorical. It's zeros and ones. So we're going to include that there. So when we're in our regression analysis, you know how we can interpret like a slope of our line or the y-intercept, and we could still do that all the same that we did before, but how do we interpret this categorical, right? So let's talk about that because everything else is really the same as before. It's just now we need to look at how we're going to do this. So to interpret the indicator variable and the coefficient. Okay, so how do we interpret this coefficient of this indicator, that categorical variable? So we're not going to use the typical slope interpretation that we're used to, right? We're used to using that, and we can use that for all the others. But for the categorical variable, we have to use something a little different. And it's because it's a 0, 1. So either something takes place or it doesn't take place. So think about it in that way, a 0 or 1. So we can say that the coefficient is the average difference in our y variable between the meaning of a 0, and I'm going to fill this all in, and the meaning of a 1. So you're going to write it out, right? What the meaning of a 0 is. So you could say the coefficient is the average difference in salary between males and females, right? So that's what I mean. When I say like meaning of a 0, meaning of 1, what does 0 stand for? Males, and 1 stands for females. So the coefficient is really something you're filling in, and I apologize. I did not do that right. So the coefficient, so whatever that value is, so that's the average difference between a 0 and a 1. Okay, so I'm going to write down what this means to us because it kind of can be, I don't know, I don't want to say weird, but I want to just clarify this is what I want to say here. So the coefficient I really want a new pen. Let's switch this out here. Oh, there we go. Oh, well, maybe this one's dead. Is the effect, this one is. Sorry, guys, it's a mess. Okay. Is the effect that the meaning of a 1 has, let me write number 1 like that, has on the response variable. So the coefficient is the effect that the meaning of a 1 has on the variable, okay? The meaning of a 0 is having no effect on the equation. Okay. So what we're looking at is if you have a 1, this means it happens. Okay, so kind of think about, you know, when we code stuff 0 and 1, 0 means it doesn't happen, 1 it means it does happen. Okay, so this means the equation is changed by 1 times the coefficient. Okay, view it like that. Then if we have a 0, then this means that it does not happen. And what this means is that there is no change in the equation. Okay, so no change in the equation. I'm talking about the regression equation. And because it is 0 times the coefficient. That makes sense? Oops. Okay, so if it's a 1, it means it's happened. So maybe the female is what we were really interested in. So we had coded female as 1. Then the coefficient of that variable, whatever it is, whatever that number is, it's just multiplying it by 1, and the equation will change by that. So if it's positive, it'll increase, right? If it's negative, it will decrease. If it's a 0, it means it doesn't happen. So it means not female, it's female. And then it'd be no change in the equation. It would be like 0 times the coefficient, right? So it'd be no change in that equation at all because this would be 0. Okay, so that's what we're looking at. And I'm just going to write that down, a positive. I just like to have it all written down so we all have it here. Coefficient increases the response variable by that coefficient amount or value. And then a negative coefficient decreases the response by that coefficient.
You're off the page a little bit.
Oh, thank you.
All good, all good. Just wanted to thank you.
It's like sometimes I look up and then other times I don't. A negative coefficient decreases by that coefficient amount. Okay, so positive you're adding, negative you're subtracting. That's it. I already said it, but I like to write it down so you guys have that. So this is the effect of this categorical variable. So I want you to know you're going to see this in your equation. And when we work on this example, we'll talk about it and we'll look at how it looks and what it means to us. But this is how we're going to interpret it, okay? So it depends if you have a 0 or 1, how it's going to change. And that's why you interpret it the way I wrote it before, but I don't want to move this page since I was off the page and not writing. Okay. So we are going to look at an example. And the example, I'm going to write it down here, is example 1, and it's on page 5 of the take notes. You guys were on day 24. Can you believe it? I cannot. We have like one more new lecture. Then next week we'll review for the final. I just can't believe it already. It's like a little sad for me. I'm just leaving this up since I was off when I was writing for just a second. So on day 24, example 1 is on page 5. There's data to go along with this. If you would like to download the data and take a look at it there, feel free to do that. Or if you just want to follow along and watch me, either one works. Okay. As always, I update these notes and put them in oh, sorry, I'm on the wrong thing. I put them, up on the screen and everything for us to have these. So, okay. So let me just make sure I'm on page 5. I am page 5. Here's my example. So we're studying commission versus profit. I want to know for this marketing manager's office, for an office products company, we're trying to evaluate the field sales representatives. Okay, so performance. So we want to know, does commission structure have an effect on profit? So we have 51 observations, and the variables are the district numbers. So that doesn't really mean anything to us for what we're calculating, right? The profit, right? So the profit margin for each representative, the area of the district, so in thousands square miles, so with the size, right? The population, the number of outlets in the district, and the commission. Okay, now the commission, there's 2 types. They have fully commissioned reps and partially commissioned with partial salaries. So that's what we're looking at. We want to know, is there an effect there? That's my categorical. And you can see here, it says, okay, if they're fully commissioned rep, we're going to look at a 1. If they're partially salaried, we're going to look at a 0. Okay, and we're going to code them that way. So I'm just going to skim through the problem because I like to do that. I like to know what I have to do. So it says build a matrix plot, which is not a surprise. We just talked about that. The correlation values. I want to identify the strongest relationship. I want to interpret the coefficient of area. Now that's just a regular X predictor that's numerical. So I'm going to use my normal way. And then it says interpret the coefficient of commission. Now that one's my categorical. So that one's new for us today. Then it's going to say, is the regression significant? So that's shortened test process. So I need to build my model, right? Well, really before I interpret my coefficients, but we're going to do that shortened test process where we read all our output, same as before, same as last week. And the individual predictors. Remember, we get that from the coefficients page. Nothing new there. Everything's the same. Okay, so now I want to answer the main question. Does commission structure have an effect on profits? I want to know, does it? Right, and we'll look at that together. And so do we feel comfortable using predictions? This is my R-squared adjusted, right? And then it says to find the average profit. So I'm actually going to predict a value. This is new, like with multiple linear regression, right? We've done this with simple linear regression. We've used the predict button. We can do it again. Remember, you can always do this by hand by plugging everything in to the equation. It's not hard, but Minitab can do this for us. Okay. Then complete residual analysis. Remember, that's my requirements, checking the 4 requirements. Okay. So I want just to see, because if it asks me for a CI, then I want to ask for those expanded tables, but I don't see a CI in here. You will see it on your daily. I just like to know, so when I get into Minitab, I know like what I need to get all at once. Not that I can't go back in. I just like to get it all at once if I can. All right, so I'm going to share my screen over. Oh, sorry, Jeffrey. I'm just seeing your message now. I'm so sorry about the notes. I can always pull them back up, but I'll scan them and I'll have them in there. I'm sorry. I'm just seeing that. Someone wanted me to show the notes from the previous page. I totally missed it. All right, I'm going to open up my Minitab and share this. So of course you can always download this. So you can see here, the district in column 1 doesn't really pertain to our model. It doesn't matter for us. You could just see it's like just numbering the districts for where each sales rep is. It's not part of our model, okay? The profit is going to be my Y, so I can label that Y if I want to. Remember, we can always do that. And then area, population, outlets, those are my predictors, and commission's also a predictor. Now you can see it's already been switched over to zeros and ones, okay? So it's already switched over to that numerical. I believe, I don't know if the button will be there. Oh yeah, there it is. Data, recode, and then you could do to numerical right there. So if it was, you know, commission and it had full commission or partially salaried, whatever listed there, you can go ahead and change that over to numerical if it was like that. Okay, so let's get our matrix plots. We're going to go to the same place as we always do. So graph, matrix plot, right? So nothing new there. But now once I click here, I'm not going to click simple anymore. I'm going to click with groups. Now, last week we noticed we could choose each Y versus X, and it gets rid of the X versus X. So if you want to play around and try that, I'm not really sure what the Mac users looks like. They probably have something similar. But either way, we're looking at the groups. And we might as well just keep doing it the way we've been doing it. So I'm just going to stick with this one on the top. I click OK. So remember what we did before. We brought in our Y variable first. So that's the profit, right? We brought that in first, and then we brought in all of the other predictors. So I'm going to go ahead and bring in area, population, outlets. Now I'm not going to bring in my categorical variable here. I'm going to bring it in the next box below where it says categorical. So here, by doing this and bringing commission down here, it will separate it out by colors. These are the groups. When I said with groups, these are the groups. It's going to separate it out. Okay. Now, keep in mind for me, and I know Mac users don't have this option, and it's okay. I usually just click on the options and I view the upper right. What it does is it just gives me just the scatter plots I need. So it gives me, if you don't click the upper right, it just gives you double the number of scatter plots. Okay, it just gives it to you the other way, right? So it's okay. You could just get the full thing and look at the upper right, or you could just ask for the upper right, but I feel bad. I apologize. The Mac users, they don't seem to have this option, and I apologize for that. But if you don't have, let's just view it full, and we'll just see what it looks like. You don't have to look at all of them. It's kind of a lot going on. And so the upper right, you can see that the diagonal here split, right? I'm going to ignore that lower left. I'm just going to look at this upper right. And that's what I mean. So when I ask for upper right, it just gives me the upper right. It doesn't give me the lower left. All it does is it switches the order around. You could see that, right? It's the same scatter plots. It's just switching the order around. So you don't really need that lower left. The reason why I ask for upper right, because I put profit in first, and I want to just look at that top line. So that top row of scatter plots, this one right here, right in line with profit, because that's the profit is my Y versus area X, population X, outlets X. Okay, so that's what I'm really looking at. So I'm going to kind of zoom in on this top row here. So look at it, looks like the area has a negative linear relationship, and I believe population was the second one, and that one looks like it's a positive, and the outlets looks like it's a positive relationship. Now, the strongest one, it's hard to tell, but it almost looks like area is the strongest. So this first one, right? The dots are clumped together a lot closer, right, than they are over here. I bet they're pretty close, R values. So we can get those R values and just confirm before we talk about area versus profit. What I want you to look at here is look to see if there's a separation in color for red versus blue. Look at this one. It looks like all the reds are towards the top and the blues are towards the bottom, right? Look at same over here on this one, next one. The reds are along the top and the blues are towards the bottom. Same with the last one. It appears like there's a separation, but it appears like there is an effect for the type of salary that someone has. So it looks like the one, which I forgot which we did for the one, I'll have to look, has, right, they have a stronger profit. And that means something for us. That's what we're studying. So let's take a look at my stat basic. I'm gonna go back down to this correlation. Remember, this is the only thing that's under basic stats, is that correlation. You go for this, you go here for all the correlation. It doesn't matter if it's simple or multiple linear regression. Click on that. Remember, for this one, I bring it in last. So I bring in my response last. And here you are not going to bring in commission. So I'm going to bring in area, population, outlets, and then profit. The reason why I do this is just so now I can look at that bottom row and just quickly skim and look at that. Okay. So I'm not bringing in commission here. This is just a calculation. Of course, I get my plots here, but if you don't bring in commission, then the plots don't mean anything to see if there's an effect on that for that commission, right? That categorical variable. You still get the same plots and you could see if there's a strong linear relationship between X and Y, but you don't know if the categorical has an effect. Okay. So here's my profit. It's down at the bottom because I brought it in last, and I can just look at the bottom row. So it's not as strong as a relationship as I was thinking it was going to be by looking at the plots, but definitely area is stronger, and I knew it would be close to population, but we can see it is stronger. It's 0.69. It's just on the negative side, right? And that's okay. It's still the strongest linear relationship. So I'm definitely going to say that profit and area have, I would say, a negative moderate strength linear relationship. Okay. Then I'm going to go back here and I'm going to look here and I can say, well, it definitely appears like there's a difference. Now I have to go back to my problem and see. I'm just going to look. Okay. So the one is fully commissioned and the zeros are partially commissioned.
I have a question, actually.
Yeah.
Can you go back to the correlation?
Yes, I can.
I don't know what the name of this is, POPN. Isn't that stronger than the profit?
No, the population, look at it, it's 0.602.
Okay.
The profit's 0.69.
Okay.
Remember, it doesn't matter positive or negative, but the closer to 1 or -1, the stronger the relationship. So the closer to 0, the weaker the relationship. Okay. And that's what we're looking at. So it's just negative. It's okay. It's still the strongest relationship. It's just negative. It just means that as X is increasing, Y is decreasing, but it's still a stronger linear relationship. I'm really glad you asked that because I bet there's other people that are wondering that. So thank you for that. So the ones, the red is the fully commissioned reps. So if we look back here at our scatter plots, we can see that it appears that the fully commissioned reps have a higher profit. Like to me, it looks like there's a difference, like a separation in color. And I'm going to mention that in my interpretation. Okay, right when I talk about area versus profit. Does that make sense to everyone? Okay, so let's build our model. So we will go to stat, regression, fit our model. Same as we go, doesn't matter if it's simple or multiple linear regression, right? So my response is profit. Now my continuous predictors, I'm going to put all 4 in: area, population, outlets, and commission. I still do not use that last box. I am not using the categorical predictors because now I've numbered it 0s and 1s. Okay, so I'm putting it right in with my continuous predictors. So all of them go in the second box. Do not use the third box. Now, remember it did say continue with residual analysis like at the end. So if I want to check my requirements, my residual analysis, I need to get my graph from here in my storage. So I'm going to do that now. So under graphs tab, I ask for standardized residuals, and I'm going to look at that residuals versus fit plot. This doesn't change. This is like the same process that we do right back from simple linear regression. Okay, click OK. My results, if I'm asked for a CI, I know I'm not today in this example, but in the daily you will be. You'll just ask for expanded tables like you usually would do. Click OK. And then the last one is storage. So remember the storage, I have to ask for my residuals so I can run my NPP. I typically ask for the standardized residuals since that's what I did for my fits graph. It doesn't matter if you do regular residuals, you'll get the same results as me in your NPP. So I just click on these bottom three and I get all that information out. So I'm just going to click OK and you'll see, oops, I have it all zoomed in. My model is built here. Right, so we get a lot of information, like the output, there's quite a bit, but we actually use a lot of it as well, right? So when I'm starting, I'm really looking at my equation and I want to look at this equation with you guys. So 700 is my y-intercept, right? And then here's my negative coefficient in front of area, which I knew was going to be negative, right? Because I saw that in the picture and my correlation is negative. So it just means as X is increasing, Y is decreasing. So that should be negative. The other ones should be positive. So population's a positive 104, outlets is a positive 0.76. And look at here at commission. So commission's my categorical variable. This is like the new part today. This is really what we're studying with, that's new. And so the commission, so what it means is if someone is a fully commissioned rep, that means they're a 1, that means that their profit is going to increase because it's a positive by 330. I believe this is in dollars, maybe. I have to double check. Yeah. Okay. If they're a partially commissioned sales rep, right, where they have partial commission, partial salary, that means they're a 0, okay, if that's the case. So it'd be taking that 330 times 0. It means it does not change my equation at all. It just would be plus 0. Does that make sense? So it means there's no effect. So it increases if they're a fully commissioned sales rep. It doesn't change my equation at all. It's not like it decreases it. It's multiplied by 0 because that's what that means. Okay, so I want you just to know that's how the equation looks and that's how it's changed. And I think it asks for that in the write-up. So I would just say 330.2 is the average difference in profit between being a fully commissioned sales rep and a partially salaried sales rep. Right? And that's that difference. All right. So now we're asked to run a full test. I'm going to go back over to the write-up so we can see what the write-up looks like. It's the same thing as before. So I'm going to go back to my typed notes and scroll down to the completed example here. So we could just see everything's here, see all the write-up. But what I want to look at is my significant regression. So I want to know if my model is useful, statistically. So remember what that means. It means that one of the slopes are different than, I say slopes, one of the coefficients different than 0, right? So the slope is different than 0. So here, remember we just identified the null, that they're all the same and that they're all equal to 0. HA's at least 1 is not 0, right? I'm going to read my F-test statistic, my degrees of freedom, just like we did last week. So let me find my output here. I didn't paste it. Why? I'm sorry, I have to flip back because I really want to show you where it is just in case someone missed it last week. I apologize. I didn't realize I didn't paste it in there. I should have. Okay, so for my F-test statistic, you come down to analysis of variance, the same as last class. You're going to look under the regression row. It's the top row. My F-test statistic is 22.32. My p-value is very small. My degrees of freedom, 4, 46. Okay. So here we can say that I do have a significant regression because my p-value is less than 0.05, right? So what this tells me that something is significant. It tells me that at least one of my coefficients is different from 0. It just doesn't tell me which one is. And there might be multiple, right? They might be all different from 0 statistically, or it might be just one, but it will be at least one in that case when my p-value is very small. Okay. I believe the next part of the output was pasted over here. I apologize. I'll fix that and re-upload the notes. Okay, so right here. Okay, so I just said at the 5% level, significance of sample does provide sufficient evidence to say the model is significant or statistically useful. Okay, so now I'm going to look for the individual predictors. Remember, this is what we did last week, where we skimmed down the p-values, right? We're going to look at the p-values. We're not looking at the constant, so the top one doesn't matter, but we're looking at the other 4. We're going to look for anything that's less than 0.05. That means it's significant. So look at area is significant. I'm not surprised it had the strongest linear relationship, right? That we talked about. I'm not surprised with that. Population outlets are not. And then look at this, commission is significant. So I do have 2 predictors that are significant. And I would say that both area and commission are significant predictors in my model. Okay. So here I wrote them all. You know, I'm looking for the ones that are. So you do not have to, I'll gray this out. I'm going to update the notes just so it's consistent with what I'm saying. Something like this where it's not a predictor, you don't have to write that. I will gray it out so it's there in case someone wants to see it, but you don't have to include one that is not significant. I just want you to tell me which ones are significant. Okay. All right, so now it says, does commission structure have an effect on profit? Yes, it does, since it's a significant predictor. So that's how I know. So when my categorical variable is significant, so that p-value is less than 0.05, that's how I know that it is. So I just say, yes, commission status is significant predictor. So we can say that has an effect on profit. In fact, that it stated earlier in part 5 that the fully commissioned reps have a profit that's 330.2 more than the salaried. So that's what we got from when we were looking at the equation. All right. So do you feel comfortable making predictions? This is based on my R² value. So this is just, is it practically useful? So remember when I have multiple linear regression, I look at R² adjusted, that's 63%. No, probably not, because I want it to be greater than 75%. Okay. So now to this next one, to find the average profit margin. So if I want to look for a predicted value, so I want to know a predicted Y based on these different values that were given to me. So let's look at that real quick. So I'm going to go back to my mini tab. Okay. So now we did this before with simple linear regression, but I don't think we did it at all last week. So we will go back to stat regression and back to regression. And remember, now once the model is fit, I can predict. So I will do that. I'm going to go into my predict button, same place that we did for simple linear regression. I'm going to click here. And it wants me to put these values in. So everything should be filled in the way the model was built. So profit is my Y, yes, and then here's all the X's. So it tells me in the problem what they should be. So I have to look, and it says area is 15. So I'm going to plug in 15 here. Population is 3.1. Just plugging in the values that was given to me. Like I said, you could do this by hand. I believe this was 115 if I have it written down correctly. And then the commission was for a fully commissioned rep, which was a 1. So I'm going to plug this all into the equation and tell me what my Y is. Okay. I'm just going to go ahead and click OK. Remember, we're looking for that fit. I have this like all like really big. So here you can see everything I plugged in. If you want to confirm everything you plugged in properly, it's just plugged it into the equation for me and it got my profit. My fit is my predicted value. So it's 1088.92. Okay. So that's the Y when I plug in all of these values. And that's how you predict. Right, let's take a look real quick at the residual analysis. So we can all be on the same page. I think we are for the most part. We've been doing this for a while. All right, so my residual analysis right here, I'm going to look at my standardized residuals versus fits. So it looks like there's a pattern. It kind of almost looks like a V, right? Almost looks like a V pattern right here. So I'm going to say they're not independent. I think there is a little bit of a pattern. The spread seems to be somewhat constant. I know it kind of dips down in the middle here, but I don't think like that it's maybe a little bit closer here and spreads out a little bit. You could actually say it's kind of on the border. I could see where someone says, well, it's pretty spread out. And if someone else says, you know what, it's pretty close here on the left, then it gets really spread out on the right. I feel like you could go two different ways with this one. Okay. There is an outlier. Look at down here at this -4. So that's not good. So I'm not really checking off my requirements on mine. And then I take a look at my p-value. I want it to be greater than 0.05. It's not. It's 0.02 for my NPP. So we cannot assume that this linear model is valid because I have not checked any of my requirements, right? So that's not great. My residual analysis is not working out for me. So it's not a valid model. Okay, that's the quick way. This is the write-up, right? So this is what I expect to see if I ask residual analysis. It's still pretty quick. Any questions on that, guys? Remember, those take notes are up day 24. I am going to just quickly update them as you guys are working on your daily today, because I do look through them, and I did right before class, but I didn't realize on that example, I didn't paste the output, and I like to do that. So I'm going to change that, and I'll change that file. Any questions for me?